looked into this code. Okay, very simple code. We have imported the goal dataset. Right now, I have not saved this file. So if I run it again, I will get error that goal is not defined. I have not saved this file. Now I am getting this error. Goal is not defined. Why? Because the import is lost. Okay, so we need to import it again, like GAUL.
Recording started.
Recording started. GAUL. Okay, and with this we will import it again. It's imported. I will rename the variable to goal like this. Okay, that is working or not? Okay, fine. Done. Now if I click on run it again, Sentinel-2 is not defined because that is also lost. So we will click on Sentinel-2 and always remember which reset we should use, level 2A. Click on this, import. Done. And here I will change the name to S2 so that we don't get any kind of error. So now you see we have the dataset created, and if you go there, maybe in India, you will see the boundary. You see Jodhpur. Jodhpur we have chosen, right? So you can see the satellite images of Jodhpur, and these were the visualization parameters which we have discussed. These are the band names. Okay. What is the name of satellite? Sentinel-2. In Sentinel-2 satellite, you have 13 different bands. So out of those 13 different bands, we are focusing on only these 3 bands. Understood?
Just because of our icons, I can.
Because our eyes can understand this very clearly. Green means vegetation, brown means barren land, blue means water, right? These are minimum and maximum values of the study area, right? And now one problem you can see, if I keep my mouse cursor somewhere else like this, and if I run it again, what is going to happen? I will lose the area, then I have to navigate it back to my study area. This is a problematic task. So there is a very simple solution for this. What you can do is just see the code. Map dot center object, and here I will pass my area, and second parameter I will pass as the zoom level 8. I will run it. Now see. Okay, it's not working. Why? See this. It's not working because right now what is this? This is only area filtered images, right? This is the image. This we should not take. This is satellite image. This is not the area. What is the area? Jodhpur is the area, not the name of satellite image. Understood? Now see. क्यों नहीं work कर रहा है? अरे
area filter image ला.
Sorry. You see. Now it's automatic zooming to the concerned area. For example, the map is anywhere. I will click on run. It will automatically center my object to my study area. Understood? Okay. You can see the area very clearly here, like this. Got it? Okay. What is the color combination right now? It's B4, B3, B2. Okay. This is called as RGB color variant, which our eyes can easily intercept. Okay, there are different color variants as well. For example, if you go through this website, Sentinel-2 band combination, just go through this website very carefully. Here you will have different band. These are the 13 different bands you have, and out of which we are focusing on 432. Read this: red, green, blue, RGB 432. You can try this band as well. 843. 8 meaning visible and near infrared. Then green, then blue. This is called as color infrared band combination. And what is the beauty of this band? It can easily reflect, just read this line. The color infrared band combination is meant to emphasize healthy and unhealthy vegetation. Right? whenever you are seeing the red color, the dark red color means the vegetation is healthy. And you can easily distinguish between water and non-water bodies using this band. So what I will do is, I will create one more variable here. Visparam is one already there, I will create another one, Visparam 2. Okay, or maybe I will rename it as Visparam NIR, near infrared. And here I will change the band order. I will make it as 8, 4 and 3. And here I will create one more layer like this. What I will change here? The parameter. This is NIR, right? And here I will change the value like this. Done? Now I will click on run. Now see the magic. You see, 2 layers are created, S2 and S2 NIR. Now see the difference. Whatever the green area, it will look like red. So you can easily distinguish between healthy and unhealthy vegetation. See this. This is the natural color combination. This is near infrared combination. And see this one. Here there is some water. I think this area is some water, right? We will just focus on the natural color band. Urban area is very clearly visible here, you can see. Urban areas are very clearly visible. Okay, and this is water body. This is water body, black color. Water body is there, right? But this is water body, but you can get confused with green and black. If you see little closely, it might look as green color, so it might be confusing, right? So when you are doing the training, here you are going to use the supervised classification. So what is supervised classification? When you have the labeled data, when you are manually labeling the data. Now if you train this model, you will get confused that is it a water body or is it a dense vegetation, healthy vegetation. So to avoid such kind of confusions, what you can do is, you can always refer to near infrared band. Now see the magic. Water is black now. And vegetation is dark red. If you look at this, you will get confused. But if you look at this near infrared combination, it's very clear. You see this area. Sometimes what happens is that in the water body, there might be some algae bloom. So from the upper side, it looks like a vegetation area. If you take a photograph from the drone, it will look like a land, it's a vegetation land. But in reality, it's a water body. So now if you see this water body, see this lake. You see this. If you only focus on this band combination, then you will confuse it as a vegetation area. You will get confused because it's also green, this is also green, this is also green, looks like vegetation, but in reality it's water. So this is the power of using different band combination. See this. This is vegetation, this is water. See the difference. These are water bodies. This is water, this is water, this is water. So like this way, you need to use different band combinations in order to classify your study area. Understood? So this is what you have looked today. I will save this code and maybe I will name it as G Research LULC training class. We will do all the code in this file only, right? So this is how you can create different try to understand the logic. No need to remember the code. Code you can get from ChatGPT directly, but you need to understand the logic why we are doing this, why we are using different band combination in order to do the classification, right? Now this part you understood, right? In the next phase, what you need to do is you need to create the training samples. You need to divide the area into different kind of training samples. right? How to do that? Understand this. Before proceeding further, can you tell me how many classes are there by looking at this image? I can identify 4 classes. Vegetation, water bodies, very little water is there. Vegetation, water bodies, then there is urban area. If you see this, this is a urban area. Okay, and there is a barren land. 4 classes I can identify very clearly. So for each class you need to create training samples. How to create training samples is very easy. Go to the Google Earth engine, go to this marker, add a marker, right? Here you click on this setting icon. Now check the settings very carefully. If needed, watch this video again. Here you cannot make any mistake. Okay, what is this? Name. I need to name the class. Maybe I want to name it as water. Okay, import as geometry. This you need to change. You will change it to feature collection. Don't forget this. Not geometry, not feature, you will change it to feature collection. Because it is water, then you need to give it blue color. Okay, in the property you make, now it's very important, here whatever you are writing, it will not change. If you are making it as class, always keep it as class. If you are making it as land cover, always keep it as land cover. The property should not change, the value can change. Class value 0. Okay, what are the parameters we have used? Water, blue color, class 0. Okay. Now whenever you are seeing the water, you can create the training samples like this using your mouse. Wherever you are seeing the water, you just create the training samples like this. Now the question is, how many training samples you should create? There is no such rule. There is no such rule how many training samples you should create, but keep in mind, create almost equal number of samples. For example, if you are taking 80 samples per class, 80 samples for water, then for each class you should take near 80 samples, maybe 75, 90, or if you can match the exact number, that would be much better. First rule. Second rule, this is very big area. This is a complete district of Rajasthan, right? It's a very big area. Never take samples from only one region. Try to go through this image completely and take samples from many different locations. For example, here also you can see some water area. You see? Here also some water area is there. So try to take samples from distant places so that your model does not get biased. To avoid the biasness, you should take samples from the complete image. Each part of the image should represent some kind of training area. For example, you can see water here, very small area. You can see water here, very small area. Understood? By mistake, you chose the wrong sample, you can delete it. You just click on this hand icon, click on this, and you can see the delete icon. Or you can move as well. Now one question, what if this is water, right? By mistake I chose this. What will happen? Your result will get destroyed due to one wrong sample. Why? Because one sample is saying that this is vegetation, but I am training it as water. So because of one sample, my whole classification result will get wrong. So that taking sample is very crucial step, and you should create samples very carefully. Let's create another layer. I will call it as vegetation, and here I will change the color to green. Feature collection. What will the name of the class? Class, and value 1. Sequence 0, 1, 2, 3, 4, and so on. Vegetation. This is vegetation, this is vegetation. Very easy in the near infrared band combination. This is vegetation, this is vegetation. Try to take samples from distant places, not nearby samples. This is the common mistake we used to do. Like this. Okay, let's create another category, maybe, and you can see the variables are automatically created here. Feature collection. right? Maybe I will call it as barren land. I will make the class name as maybe brown or something like this. Okay, feature collection class 0 1 2. Okay, name must be alpha and start with a letter.
Space.
Space letter. Like this. This is how you create the training samples. Then maybe another category you can call it as urban. Class 0 1 2 3, yellow color. This is urban area. This is urban area. Okay. Urban area is very less in Jodhpur. Mostly because it's a क्या बोल रेगिस्तान को क्या बोलते हैं? Desert. Mostly it's a desert area. That's why it's not green. It's brownish from the satellite. See? Very small area is there. This white pixels. These are urban areas. These are not desert. These are urban areas. So this is how you create different training samples, and you can see from here. And the variables are automatically created here as well. Water, vegetation, barren, urban, like this. Understood? So this is how you create the training sample. I will save it. I will stop the recording.